Okay, so good day to all of you. So we're already in chapter 6 of the systems analysis and design, which is called object modeling. So object modeling is another way to represent an information system aside from the data and process modeling. So in data and process modeling, we have learned how to create data flow diagram or the DFD, decision table, and decision trees. For object modeling, there are also sets of diagrams that we're going to learn here that is very important for object modeling. So let's start chapter 6. So the chapter objectives explain how object-oriented analysis can be used to describe an information system, define object modeling terms and concepts, including objects, attributes, methods, messages, classes, and instances, and then explain relationships among objects and the concept of inheritance, and draw an object relationship diagram. So aside from those objectives, describe unified modeling language or the UML, tools and techniques, including use cases, use case diagrams, class diagrams, sequence diagrams, state transition diagrams, and activity diagrams. And then explain the advantages of using case tools in developing the object model. And then explain how to organize an object model. So for the introduction for this chapter, you learn about object-oriented analysis, which is another way to view and model system requirements. And then you use object-oriented methods to document, analyze, and model the information system. So for the overview of object-oriented analysis or the OO analysis, so by the word itself, it deals with objects. So OO analysis is a popular approach that sees a system from the viewpoint of the objects themselves as they function and interact. So what we're going to do here to make those diagrams, those identified such as use case, class diagrams, sequence diagrams, and the like, these are called the object models. So, but before that, let's have an object-oriented terms and concepts. So we have a unified modeling language. So this is used solely for object modeling. And then we have attributes, methods, message, class, and instance. So for attributes, methods, and message, so we have to look for this example. So interaction between objects. So we have an example of a car. So attributes, so we have the car object has characteristics called attributes such as make, model, and color. So attributes are characteristics. And then next is we have messages. So for this situation, the driver object send messages to the car object such as clean the windshield or slow down. So that is a message. So it's like a literal message such as, for example, clean the windshield and slow down. And then how about the methods? So the methods, how will the car object react to the message of the driver object such as clean the windshield is operate the wipers. And then if the message of the driver object is slow down, so the method is apply brakes. So this is the methods or actions. So then for the class, so objects are categorized based on classes, and there is also the instance, and this will be discussed on following slides. Okay, so again for objects, so we have an example here of a parent object. The name of the object is of course parent, and then the attributes at it as is it said, these are characteristics that describe the parent object. So the attributes of the parent are the name, age, sex, and hair color. And then the methods, its definition, tasks that the parent object can perform. So the methods for this example is read bedtime story and drive in the carpool. So the instances are example are the database or a record for a particular object. You can think of instances as like that. So we have instances of the parent object. We have three. Specifically, we have Mary Smith, that's the name, and then age is 25, female and red hair color. Ahmed Ali, age 34, male and brown hair color. And then Anthony Green, age 42, male and brown hair color. So this is an example of an object with its instances, and then this is an example of course, a parent object. So another object is the child object. So the attributes of the child object are the name, age, sex, hair color, and number of siblings. And then the methods: pick up toys, eat dinner, play, cooperate, get ready for bed. So for this example, the child object has also three instances. So we have James Smith, age 3, male, red. It's not only indicated the number of siblings. So Amelia Ali is age 1, female, and brown hair color. Then Misty Green is age 12, female, and blonde hair. So these are the example of a child object and its instances. So another example is we have the dog object. So the name of the object is dog, and the attributes of the dog are the name, breed, age, color, sex, and favorite food. And then the methods of the dog is wagtail, eat, fetch, and sleep. So the instances of the dog objects are, we have the name Buddy. The Buddy is a terrier mix, age 12, white collar, male, and favorite food is kibbles and bits. For Annie, she is a West Highland Terrier, very young, age 1, white, female, and her favorite food is Pro Plan. And then Megan, she is a Poodle mix, age 8, color is tan, female, and her favorite food is Purina Dog Chow. So, we have also another, aside from those objects, so we have these two objects, the student and instructor object. As we can compare, there are objects that have the same attributes. So, what are the common attributes or the same attributes of student and instructor object? We have the name, the address, the telephone, and the status. And then, do they also have the same methods? They have also, such as change address, change telephone, and change status. So they have common attributes, but they have these unique attributes that differs this one object to another. For example, for student, what makes a student object different from an instructor object, such as the attributes of the student object has a student number, then date of birth, and fitness record. While as the instructor, what makes the instructor object different from the student object is that the instructor has an instructor number, a fitness classes taught, availability, and private lesson fee. And then again, for methods, what makes the student object different from the instructor object by means of method is that the methods of the student object is they have these methods such as add fitness class, drop fitness class, and update fitness record. While again, the instructor object differs from the student object because the instructor has teach fitness class, change availability, and change private lesson fee. So this is an example of objects with common attributes, but then again, they have these unique attributes and methods to distinguish them from one object to another. So attributes, if objects are similar to nouns, attributes are similar to adjectives that describe the characteristics of an object. Some objects might have a few attributes, others might have dozens. So attributes also have their state. Okay, next is for methods. A method defines specific tasks that an object can perform. Just as objects are similar to nouns and attributes are similar to adjectives, methods resemble verbs that describe what and how an object does something. So for this example, our method is more fries. So the method has the following steps. Number 1 is heat oil. Number 2, fill fry basket with frozen potato strips. And then lower basket into hot oil. Check for readiness. Number 5 is when ready, raise basket and let drain. Step 6 is pour fries into warming tray. And then step 7 is add salt. So this is for method. And then we also have messages. We have this so-called polymorphism. Polymorphism means you have the same messages, but does this message have the same methods that is to be done by an object? Example. So let's look at the example of how polymorphism works. Example, the message is good night. So if the message is good night and received by the parent, so what will be the parent's method? So we have this description, causes the parent object to read a bedtime story. So that's the parent's reaction to the message good night. How about the dog? So the dog, when the dog receives the good night message, so causes the dog object to go to sleep. And then how about the child? When the child receives the message good night, so causes the child object to get ready for bed. So this is an example of polymorphism. Again, same message, but they have different methods for the message. What if there's no polymorphism? Example, the dog. If there's no polymorphism, is it possible for the dog to read a bedtime story? Of course, it's impossible. In a real world situation, it will never be possible that a dog can read a bedtime story. So that is the meaning of polymorphism. And then, of course, black box, just as like with the data flow diagram, the process is a black box. It's also a black box because it only tells you what is done, but not how it is done. And then because of it, we have this encapsulation, meaning there are the other components of the object is not shown, such as this one. Since the message is good night, the only accessible methods for it is, for example, read a bedtime story, go to sleep, and then get ready for bed. But the other methods are not available. So that's the meaning of encapsulation. You're protecting the object's components to so that, of course, for security reasons. So next, as we have for the messages, a major advantage of OO designs is that systems analysts can save time and avoid errors by using modular objects, and programmers can translate the designs into code working with reusable program modules that have been tested and verified. So we have an example. So the message is enter grade. So the instructor will enter grade to the student record. So next is we have classes. So an object belongs to a group or category called a class. All objects within a class share common attributes and methods. So we have subclasses and superclass. So to differentiate between subclasses and superclass, let's have this example. So our class is we have vehicle. So the attributes of vehicle is the make, model, year, weight, and color. And then the methods is are rather start, stop, and park. Okay. So the vehicle has its subclasses such as car, specific vehicles to be exact. Car, we have minivan, truck, and school bus. So car and minivan, they share the attributes of the vehicle, all of the attributes. So there are no changes for the subclass of vehicle, which are car and minivan. While for the truck, it has the attributes of the vehicle class, but it also has its unique attributes such as load limit for the truck. And then for the school bus, we have emergency exit location. Again, that is unique for the school bus subclass. So again, car, minivan, truck, and school bus are subclasses of vehicle, while vehicle is the superclass of car, minivan, truck, and school bus. So this is the difference between a subclass and a superclass. So next is we have relationships among objects and classes. So as you can see for the previous example for the vehicle, that the subclasses share common attributes to the vehicle. So that actually is called inheritance. And then vehicle is considered a parent, while the subclasses, the car, the minivan, the truck, and the school bus, they are considered as child. So we have this inheritance visible to parent and child, such as, for example, the parent is employee object. So the employee object has the attributes such as social security number, telephone number, hire date, title, and pay rate. So since this is a parent and then instructor is the child, you can see that the instructor object inherits the attributes of the employee object such as social security number, telephone number, hire date, title, and pay rate. And to make the instructor different from the employee object is we have the attribute type of instructor. Not just the attributes, but methods can also be inherited. So we have the methods of employees such as get hired, terminate, change telephone number. As you can see with the instructor object, it is also inherited by the instructor object. Get hired, terminate, and change telephone number. So there is the so-called inheritance from a parent to a child. So for this example, we have employee as the parent and instructor object as the child, and there is inheritance. So another way of drawing or visualizing the relationships among objects and classes is the use of the object relationship diagram. So for the object relationship diagram, you should know the context, you should know the structure by observation or by documentation, and by means of that, identify the objects. So for this example, the objects are the employee, manager, office staff, instructor, fitness class schedule, registration record, fitness class, and student. So, by means of identifying the objects, create arrows or connect them by using arrows and then determine their relationship, such as, for example, employee is connected to the manager, office staff, or employee is an instructor, is an office staff, or employee is a manager, or office staff is an employee. And then manager determines fitness class schedule, and then fitness class schedule lists open fitness classes for the registration record, and then the office staff administers registration record, and then instructor indicates availability in the registration record. The instructor teaches the fitness class, and then the registration record generates roster for the fitness class, and registration record adds student, and student takes fitness class. So again, object relationship diagram can be created if you already familiar or you have identified objects in a given situation or context. Okay, next is we have object modeling with the Unified Modeling Language or the UML. So the UML uses a set of symbols to represent graphically the various components and relationships within a system. It mainly is used to support object-oriented systems analysis and to develop object models. So our first diagram for UML is we have the use case modeling. So use case modeling is composed of an actor. So actor actually is a person. It's just like not unlike with data and data flow diagram is that the entity can be a person, a thing, or an institution. But for use case modeling, an actor is actually a person. So an actor, for example, is drawn like this. And then we have the actor passenger, customer, and then the bus dispatcher. And then the symbol for a use case is an oval with a label that describes the action or event. So just like the DFD, so the use case is an oval and then a verb. Make, actually to be exact, is we have transitive verb because we have a direct object. Make what? Make airline reservation. So the customer place order, place what? So place order verb and then direct object, and then change pickup address, then change and then pickup address. So the use symbol for a use case in an oval with a label that describes the action or event, so verb and its direct object. Then use cases also can interact with other use cases. So this is an example for identifying, for example, a for use case. We have the actor and then we have the action or event represented by a symbol, drawn by a symbol. Okay, so for use case modeling, when the outcome of one use case is incorporated by another use case, we say that the second case uses the first case. And then we also have this use case description. When you identify use cases, try to group all the related transactions into a single use case. So the collection of use cases is called use case diagrams. So this is already an example of use case diagrams. There is an interaction between the use cases, and then we have the system boundary. So this rectangle here is your system boundary. Okay. So after you identify the system boundary, you place the use cases on the diagram, add the actors, and show the relationship. Okay, just like the data flow diagram, to have or to easily create the use case diagram, you should be familiar or you should know the step-by-step procedures. So for example, for the use case diagram of auto service department, for this example, the identified steps are create work order, update work schedule, and prepare invoice. And then for these processes or for these steps, who are the persons involved? So you have to, of course, know who are the actors involved, such as the customer, the mechanic, and then the service writer. So for example, your use case is create work order. So the customer, how does the customer um uh, relates or reacts or affects the create work order? So the customer requests service, so there is create work order, and then the service writer writes the create work order, and then after that the request and the service writer has written the work order. The create work order will update the update work schedule and the prepare invoice. So the mechanic will be notified about the update work schedule, and then the mechanic performs prepare invoice. And then of course the service writer checks the prepared invoice. So this is an example of a use case diagram. Again, to make the use case diagram easier, you need to have already the documentation or you already know the step-by-step procedures for you to create use case diagrams easily. So next diagram is we have the class diagram. So evolves into a physical model and finally becomes a functioning information system. Each class appears as a rectangle with the class name at the top, followed by the class attributes and methods. And then the unique feature of this diagram is what you call the cardinality. So this is an example of a class diagram. So the identified classes are, we have the sales manager, the sales rep, sales office rather, customer, order, and items ordered. And then the verbs that used here depends upon again to the documentation or the step-by-step procedures or the given context or situation. And then what we said here is the cardinality is this, we have this one or then zero and then asterisk and then one and then asterisk. So later on, I'll teach you how to read these class diagrams. And of course, these classes have their own attributes and methods. So for simpler or easier to understand, attributes and methods are not explicitly stated in here. But these are the class diagrams for easier explanation. Okay. So we have the relationship between sales manager and sales rep. So how to read this relationship? So one sales manager manages zero, and then the asterisk is read as more. So sales rep, again, one sales manager manages zero or more sales rep. So it means that sales manager okay, it's not, why is it zero? It depends upon the description of the situation. Okay? So the sales manager is still a manager even though he or she is not managing, there's no sales rep at all. Okay? And at the same time, you read it in reverse, but you have to change it since one sales manager manages zero or more sales rep. So zero or more sales rep is managed by one and only one sales manager. So it means sales representative can only be managed by one and only one manager. Sales representative cannot have two or more sales managers as their boss. Okay, so that's the meaning of the relationship. So another one. So one sales manager manages one and only one sales office, meaning sales manager will only manage exclusively one office. He or she cannot manage two or more sales offices. And then also, one sales office is managed by one and only one sales manager. And also, sales office cannot have two or more sales manager. Okay, next. So, zero or more sales rep is assigned to one and only one sales office. Just like the sales manager, sales representative cannot have two sales offices. They must be registered to one sales office only. And then, one sales offices uh, uh, is assigned to zero or more sales rep. So, a sales office is still a sales office even though the sales office have a zero sales rep or no sales rep at all. It's still a sales office. Okay, next is, so sales rep. So, a sales rep is uh, sales rep is assigned to one sales rep is assigned to zero or more customers. So a sales rep can handle no customers at all or one or more customers, and customer is assigned zero or more customers is assigned to only one sales rep, meaning that the customer can only be assigned to one sales rep only. They cannot be assigned to two or more sales rep because of course in a real world situation, if a customer has two sales rep, there is a possibility that these two sales rep will get into a fight or quarrel because of the customer. Okay, next is we have the relationship between customer and order. So, one customer places zero or more orders. So, even though you're not yet ordering, you're already considered a customer. And then, zero or more orders is placed by one or only one customer. So, it's not possible that for an order, you have two customers. Orders are exclusive to one and only one customer. And then also, relationship between order and items ordered. So, zero or more orders includes one or more items ordered. So, it's correct that why is it zero or more? It means that even though orders are considered, even if you're not yet paying. So that's why, so zero or more. And then, of course, if you order, you should have items ordered. This will not be considered an order if you don't have any items ordered. And at the same time, one or more items ordered is included to zero or more orders because, of course, items ordered has instances, so they can be included to zero or more orders. So this is an example of a class diagram. So you have to take note of the cardinality and the relationships between the classes. Okay, next is we have the sequence diagrams. So it includes symbols that represent, we have classes. So classes, for DFD, these are the entities. For use case, these are the actors. So that is class 1, class 2, or it depending upon the situation or context of how many classes you would have. And then lifeline. Lifeline, these are the duration of their transaction. So that's the lifeline. And then lifeline, for this example, this have an X at the end, meaning class 2 has already finished its transaction. So there will be no following transactions if, for example, for this one. So that's why this is the end of its transaction to for example, to class 1. And then we also have messages. So messages are for DFD, these are the steps of, okay. And then focuses, focuses meaning this is the interaction between class 1 and class 2, in which class 1 is active and which class 2 is active. So that's the meaning. So for this part that does not have a focus, meaning class 1 and class 2 are not active in this time. So we will get more of a detailed sequence diagram on how to do it. I'll be providing additional videos so that you will further understand of how a sequence diagram is done. Okay, next is another is we have the state transition diagrams. So state transition diagrams are applicable if your object has states. So this is an example of a bank account. So the states of a bank account is new, active or existing, frozen, or closed slash former. So this is the start of the state diagram, and this is the end of this state transition diagram. So if the customer opens an account, this will be considered as new. And then if the customer makes first deposit, it will become active or existing. If the assets are attached, it will become frozen. And then if the assets are released, it will return to active or existing. And then, if the active or existing, the bank closes the account or the customer closes the account, it will be closed or former. And then for this state transition diagram, you can see that the closed or former account cannot return to active or existing or cannot return to new. So again, state transition diagram depends on the given situation or context. So, and then, since this is the last state, and then this will be the end, the symbol for the end of the state transition diagram. So, the small circle to the left is the initial state, or the point where the object first interacts with the system. Then, reading from left to right, the lines show direction and describe the action or event that causes a transition from one state to another. The circle at the right with a hollow border is the final state. So another diagram is we have the activity diagram. So just like with the DFT and use case, you have to identify the step-by-step procedure, such as, for example, for the activity diagram, for easier creation of this diagram, is the steps are the customer inserts ATM card, customer enters PIN, then customer requests cash, and then ATM adjusts balance, ATM provides cash, and then ATM notifies customer. For activity diagram, the steps is composed of of course, the subject or the doer of the act, the verb, then the verb, and then of course, this verb is a transitive verb, and then we have a direct object. So for this one, customer enters PIN, customer requests cash, ATM adjusts balance, ATM provides cash, and ATM notifies customer. So, and then we will put um the cause. It's like cause and effect, such as, for example, if customer needs cash, then customer inserts ATM card. If card is accepted, customers enters PIN. If PIN is accepted, then customer requests cash. If sufficient funds available, the ATM adjusts balance. So since it is already automatic that the ATM adjusts balance, and then the ATM provides cash. If sufficient funds not available, then ATM notifies customer. So this is an example of an activity diagram. So sequence diagrams, state transition diagrams, and activity diagrams are dynamic modeling tools that can help a systems analyst understand how objects behave and interact with the system. So, because of these diagrams are so actually many, we have the object relationship diagram, we have the use case diagram, sequence diagram, class diagram, state transition diagram, and activity diagram. So object modeling requires many types of diagrams as I've enumerated to represent the proposed system. So creating the diagrams by hand is time-consuming and tedious, so systems analysts rely on case tools to speed up the process and provide an overall framework for documenting the system's components. So for professionals, especially for systems analysts, sometimes they can do it by hand, but then for presenting it to management, they should use case tools. So for organizing the object model, you should develop an object relationship diagram that provides an overview of the system. You should organize your use cases and use case diagrams so they can be linked to the appropriate class, state transition, sequence, and activity diagrams. It is much easier to repair a diagram now than to change the software later. So gone are the days that uh, to satisfy the clients that software or the information is done first and then the documentation is done last. Actually, that's re-engineering. But to save cost, we must repair the diagrams if these are not correct because it is costly if you will change the software later because of an error in the diagram. So for the chapter summary, so this chapter introduces object modeling, which is a popular technique that describes a system in terms of objects. And then the Unified Modeling Language, or UML, is a widely used method of visualizing and documenting an information system. At the end of the object modeling process, you organize your use cases and use case diagrams and create class, sequence, state transition, and activity diagrams. So for this chapter, so I hope that you learned or we're going to familiar with the object relationship diagram, use case diagram, sequence diagram, class diagram, state transition diagram, and activity diagrams. These diagrams are very important in object modeling. So I'll be providing additional videos for you to understand of how to create these diagrams. So if you do have any questions, please free to comment below. And then I hope that you've learned something for this chapter regarding the object modeling and the diagrams that is used for this type of modeling aside from the data and process modeling. So again, thank you very much for listening. Please, I hope that you will like the page, and aside from the page, you will like the video, and please subscribe to my channel. Thank you very much and good day.